Good day, everyone. I am Miss Vianny Agmata, the first reporter of Group 3. The topic that we are assigned to discuss is radiometric dating. Our objectives is for you to understand what is radiometric dating and what are its types. If we look through the fossils in the layers of the earth, we can easily identify which is the youngest and which is the oldest among them by their sequence in which layers do they belong, and that is we called relative dating. However, our topic, which is called radiometric dating, is more precise for the reason that it can obtain the absolute age of a fossil or any geological feature. In this presentation, we can better understand how radiometric dating works and what are its types and identification. So first, what is radiometric dating? Radiometric dating is a technique used to determine the age of materials such as rocks. It is based on the comparison between the observed abundance of a naturally occurring radioactive isotopes and its decay products using known decay rates. This technique has been the source of information about the absolute age of rocks and other geological features, including the age of Earth itself. So, technically saying, radiometric dating is a method or technique that is used by the scientists or geologists in determining the age of a rock or a fossil itself, how old they can be existing in the layers of the earth. A source of information about the absolute age of rocks, fossils, or other geological features, or even the earth itself. We can identify the absolute age of a material through the radioactive isotopes and its decay products using known decay rates. Ginagamit ang radiometric dating para ma-identify unsa nakadugay ang isa ka fossil sa layers sa Earth. But to understand better the radiometric dating, we need to first identify what is isotopes. So, what is isotopes? Atoms of the same element that contain a different number of neutrons. They share almost the same chemical properties but differ in mass and therefore in physical properties. So isotopes are the elements that has the same protons but differ in neutrons. Carbon 12 o carbon 14 ang very common nga example sa isotopes. They are both carbon but contain of different number of nutrients. They are in the atmosphere in the form of carbon dioxide. So as we all know, nga ang atomic number sa carbon kay 6. As you can see sa image nga naa sa PPT ay sa presentation, ang proton sa carbon 12 o ang proton sa carbon 14 kay both 6 kay mao man ang atomic number sa carbon nga element. However, galahi silag neutron in which ma-identify nato by subtracting the mass number sa atomic number. So, ang mass number sa carbon 12 kay 12, niya i-minus siya nimo sa 6, mahimo na siyang 6, which is mao na ang neutron sa atomic ay sa carbon 12. Then, ang mass number sa carbon 14 is 14, i-subtract na nimo siya sa 6, which is ang atomic number sa carbon 14, then ang result ana kay 8. Then ang 8 mo na siya ang neutrons. So as we can see, lahi sila neutrons. Ang carbon 12 kay naay 6 nga neutrons, nya ang carbon 14 kay naay 8 nga neutrons. In this slide is ma-focus siya sa isotopes carbon 12 o carbon 14. As you can see, nga ang carbon is ginatake siya sa autotrophs such as plants as they create glucose, which is ang glucose kay ang type of sugar that can be found in plants and fruits. Mao nang bisag walay halo ang asukal ang uban fruits kay tamis or naay lasa. Then ang isa ka animal, for example kanang kabaw nga naa sa picture, is ikaw niya ang plant, then ma-intake niya ang carbon 12 and carbon 14 in a form of glucose. If mag-remain siya alive, ang ratio sa carbon 14 to carbon 12 is mag-remain nga constant. However, if mamatay ang animal, then the consumption stops and wala na ma-add nga carbon 14. So, as the time goes by, ang ratio sa carbon-14 to carbon-12 sa organism will gradually declines because carbon-14 radioactively decays while carbon-12 is stable. Analysis of this ratio allows archaeologists to estimate the age of organisms that were alive many thousand years ago. Ang kalahian sa carbon-12 o carbon-14 is that ang carbon-12 is stable, which means wala siya ga-undergo radioactive decay, while ang carbon-14 is unstable, means gaagi siya radioactive decay. Maong ang isotop nga ginagamit sa mga archaeologists para ma-determine ang age sa isa ka fossil is carbon-14 since ang carbon-14 is ma-decay. Then, ang half-life sa carbon-14 is 5,730 years. Meaning, ang half sa isa ka butang ma-decay siya after 5,730 years if ang isa ka butang kay naay carbon-14. Moving forward, now that we understand what is isotope, I have mentioned earlier the word half-life as I am discussing the importance of isotope in radiometric dating. What is half-life? Scientists measure the length of time it takes for one half of the original isotope to decay. About 50% of the original isotope to decay. So, ang half-life is ang time and date for an isotope to decay. As I have said earlier, if mawala ang half contain nga radioactive isotope sa isa ka organism which is ang carbon-14 and then katong nga organism kay makonclude na to nga 5,730 years old na. For example, if ang isa ka scientist is nakadiscover og fossil sa isa ka animal nga naka-intake og carbon-14 pero half pa ang nabilin sa iya which is 50%, therefore, makonclude sa scientist nga kato nga fossil kay 5,730 years old. So, as you can see sa peak nga ang half-life sa carbon-14 kay 5,730 years. Makita naman ninyo nga if ang animal is buhi pa, then 100% pa iyahang carbon-14. Pero if namatay na siya, then nag-start nag-decay ang carbon-14, then 50% na lang ang nabilin ng carbon-14 dito nga fossil, which means kato nga fossil kay 5,730 years na. So, unsaon siya pagkuha? Ang half-life sa isa ka butang is i-multiply nimo sa year nga equivalent sa half-life sa isa ka isotope. So, ang half-life man sa isotope nga carbon-14, di ba, kay 5,730 years. Then, ang isa ka half-life is 50%. If isa pa ka half-life imong gipangita, 1 times 5,730 years pa na. Then, ang result ana kay 5,730 years. Pero if duha na ka half-life imong gipangita, kung tahay 50%, isa na ka half-life, then natunga na po siya, may mo siya 25%. So, ikaduha siya natunga, so duha na ka half-life. I-multiply nimo siya sa 5,730 years since mauna siyang equivalent sa isotope nga carbon-14. Then, ang result ana is 11,460. Means, if 25% na lang ang nabilin nga carbon-14 sa isa ka fossil or butang is 11,460 years na siya, and so on. Para mapadalig identify pila na ka years nga nagstay ang isa ka fossil diri sa layer sa Earth is natay ginatawag nga decay rate. Diri nga slide is makita ninyo ang decay rate sa carbon-14, which is mas mapasayo ninyo identify pila na ka dugay ang isa ka fossil sa Earth nga ka-contain og carbon-14. So, what if 70% na lang ang na-remain nga carbon-14 sa isa ka fossil? Therefore, makita ninyo diri sa decay rate nga 3,000 years old na siya. Pero what if 20% na lang, so gamay na lang kaayo? Makita ninyo diri sa decay rate nga kato nga fossil nga contain og 20% kay 14,000 years na nagstay sa layer sa Earth. There are also other isotopes that is used in radiometric dating in identifying an absolute age of rock. This includes potassium-40. So makita ninyo sa slide nga Ang half-life sa potassium-40 kay 1.5 billion years. Then, napo siya decay rate para mas mapadali niyo identify pila na ka years ang isa ka butang nga contain ng potassium-40. Kung tahay, 25% na lang ang nabilin nga potassium-40 sa isa ka butang, which is 2 half-life. Then, 2.5 billion years na siya nag-stayed ang fossil diri sa Earth. What if 4 half-lives na, which means 6.25% na lang jud siya, kanang gamay na lang jud siya, which means 5 billion years na siya diri sa Earth. In conclusion, each radioactive isotope will have its own unique half-life that is independent of any of these factors. The half-lives of many radioactive isotopes that have been determined, and they have been found to range from extremely long half-lives of 10 billion years to extremely short half-lives of fractions of a second. This table shows the half-lives of selected radioactive isotopes such as rubidium-87, thorium-232, potassium-40, uranium-238, uranium-235, and carbon-14. As I have said earlier, we can also use the radiometric dating to identify the other life forms of Earth or the age of the Earth itself. There are types of radiometric dating, which will be discussed by my partner, Clenerth Tecson.
I am Clenerth and I am going to talk about the types of radiometric dating. So, the first radiometric dating is radiocarbon dating. So, what is radiocarbon dating? Radiocarbon dating is referred to as carbon dating or carbon-14 dating, which determines the age of an object containing organic material. For carbon dating, a half-life is equivalent to 5,730 years. So, carbon dating carbon dating measures the year or how old a fossil is depending on the C14 content that is currently residing with it. So a if a organism is in full life or is living, it continuously pumps in carbon 14, and when it dies, it stops pumping C14 and gradually loses its C14 content. For example, a organism has been dead for like 6,000 years, so its C14 content is roughly at 50%. C14 dating or carbon-14 dating is it's the most accurate type of dating. However, the cons of C14 dating is it can only measure 100 to 50,000 years old. Before or after this range, there is too little isotope to be detected. And there are also other cons. Since C14 is obtainable through the atmosphere, aquatic substances cannot be measured with and cannot be measured with radiocarbon dating. Also, C14 dating can also be affected by nuclear weapons and fission bombs because they produce more C14 than what is naturally there. So next up we have is the potassium argon dating. The potassium argon dating is a method of determining the time of origin of rocks by measuring the ratio of radioactive argon to the radioactive potassium in rock. This dating method is based upon the decay of radioactive potassium to radioactive argon in the minerals and rocks. So how does this work? So the on how scientists measures this is, first off, a rock sample is crushed and the amount of AR-40 gas that escapes is measured. So what or how do they how does AR-40, or in other words argon, come in a rock or form in a rock in the first place? So first off, potassium decays by positron emissions and electrons to capture and form AR40. So basically, what they're saying is, argon comes from the decay of potassium, and then that argon gas that is stored inside the rock resides there, and as and if mas mudugay ng panahon, mas nagkadaghan ang argon sa isa ka rock kesa sa potassium. So basically, what the scientists are doing is they are measuring the ratio of argon and potassium in the rock. So if there are more potassium than argon, that means that the rock is younger, while the more argon than potassium, the more there is argon than potassium, that means the rock is older. So uranium lead dating is one of the oldest and most refined of the radiometric dating schemes. This type of radiometric dating is used to date rocks that are formed and crystallized. The half-life in uranium lead is 4.5 billion years. So uranium uranium lead dating is used to date rocks that formed and crystallized from about 1 million years to 4.5 billion years ago. So, since uranium has a half-life of 4.5 billion years, it takes that amount of time for half the original uranium-238 to decay into lead-206. So, why does So, basically how this works is the oldest uranium being the oldest, slowly decays into lead-206. The list goes like this. Uranium-238 transforms into thorium-234, then transforms into protactinium-234, then transforms again into uranium-234, then thorium-230 to radium-226. Basically, it deducts and transforms until it becomes lead 206. So an example of rock that does not contain any appreciable amounts of lead 208, the most abundant isotope of lead, we cannot assume that the lead was not present when the rock was formed. Therefore, measuring and analyzing the ratio of uranium to lead, we can determine the age of the rock. This assumes that all of the lead 206 present came from the decay of uranium 238. If there is additional lead 206 present, which is indicated by the presence of other lead isotopes in the sample, it is necessary to make an adjustment. So how they measure it is basically the same with potassium argon dating, but instead it is the ratio of uranium to lead, since lead is the decay of uranium. And that concludes the report for this topic. The references are stated down below. Once again, my name is Clenerth Tecson. My partner for this particular topic is Vianny Agmata. Thank you all for participating and have a good day.